Hello students, welcome to my channel Arun's Physics Portal. In this lecture, I will be talking about negative impedance converter. The complete note of this topic is provided here in the lecture. I hope you enjoy going through it. This topic is important for MSc, BE and BTech students of all Indian universities. Also, this will be found useful for various competitive exams like NET and GRF. So now let us come to the topic. Negative impedance converter, a circuit that gives you a negative value of an impedance. If you go to the market and demand a 47K impedance, you can get it. 47K, you can get it. But if you demand an impedance of 47 minus 47K, you will not get it. You will never get it. If you want a resistance of 470 ohm, you get it. But if you want a resistance of minus 470 ohm, you cannot have it, because negative impedance in physical form is not available. They cannot be realized in practice, but they can be realized in practice by using a circuit known as negative impedance converter that uses an operational amplifier. तो ये बात स्पष्ट है. This is clear that a negative impedance cannot be realized in a physical form. फिजिकल फॉर्म में नेगेटिव इम्पीडेंस को पाना मुश्किल है, ये नहीं हो सकता. लेकिन ऐसे इम्पीडेंस की प्रॉपर्टी को हम रियलाइज कर सकते हैं एक सर्किट से जिसका नाम है नेगेटिव इम्पीडेंस कन्वर्टर, एंड दिस कैन बी यूज्ड, इट कैन बी यूज्ड यूजिंग an operational amplifier. So let us see how this can be done. आइए हम देखते हैं व्हाट इज द सर्किट डायग्राम ऑफ ए नेगेटिव इम्पीडेंस कन्वर्टर. देखिए ये हमारा सिंबल है ऑपरेशनल एम्पलीफायर का. नेगेटिव टर्मिनल, positive terminal, this is the output here, this is output is V0, this is input here, this is Vi. Between the negative input and the output we have an impedance, I call it Zn. दूसरा impedance है जो नॉन इन्वर्टिंग इनपुट और आउटपुट के बीच में है, एंड दिस इज योर Zp. एक और इम्पीडेंस है दैट इज Z between the non-inverting input and the ground. This is Z. So this is the circuit diagram of a negative impedance converter. I assume that the current flowing through Zn is In. So In will be equal to Vi minus V0 upon Zn. This is written here. In is Vi minus V0 upon Zn. Or we can write Vi minus V0 is In into Zn. Or we can also write it as V0 minus Vi is minus In into Zn. ये हम पहले बता चुके हैं कि ऑप एम्प के दोनों इनपुट जो हैं उनके पोटेंशियल एक दूसरे को ट्रैक करते हैं. इसका मतलब जो पोटेंशियल एक इनपुट पर है दूसरे इनपुट पर भी वही पोटेंशियल होना चाहेगा. सो दैट इफ हियर एट द नॉन इन्वर्टिंग इनपुट the potential is also equal to Vi, because the potential applied at the non-inverting input is Vi. So the same potential will appear at the non-inverting input also. Now, assume that the current flowing through Zp is Ip. Then we can have Ip. We can write Ip as V0 माइनस वी आई अपॉन जेड पी। अब चूंकि ऑपरेशनल एम्पलीफायर का इनपुट इम्पीडेंस बहुत ज़्यादा होता है, theoretically infinite होता है, no current will flow into the non-inverting input. So the entire current IP that flows through ZP also flows through Z. Therefore, we can also write IP as VI minus 0 upon Z. So with these two, this is our equation 2. So the same current flows through ZP and Z. So we have equation 2 here. And therefore, V0 minus Vi is Zp upon Zi into Vi. This is equation 2. हम देख रहे हैं इक्वेशन 1 और 2 में लेफ्ट साइड दोनों के इक्वल हैं, एंड दैट इज इक्वल टू V0 minus Vi. So we have from equation 1 and 2, V0 minus Vi is equal to, from equation 1 this is minus In into Zn, and from equation 2 this is Zp upon Z into Vi, or we can write Vi upon In is equal to minus Zn upon Zp into Z. If I take Zp equal to Zn, if I equate both of them together, then what we get? We get input impedance Zi as Vi upon In. Vi is the input potential at the inverting input, In is the current. So this is the input impedance of the circuit, and this comes out to be minus Z. So this circuit has a very interesting property. The circuit that we have shown has a very interesting property, that the apparent input impedance Zi is equal to the negative of the impedance connected between the non-inverting terminal and the ground. Since the impedance Z appears to be converted to its negative value, hence the name negative impedance converter. चूंकि ये सर्किट Z impedance के नेगेटिव वैल्यू को रियलाइज करने में हेल्प करता है, हम इसको बोलते हैं नेगेटिव इम्पीडेंस कन्वर्टर. A negative impedance converter is used in various applications, including analog signal processing and control systems, to stabilize or modify the input impedance of a circuit. I assume you like this presentation. यदि आपको हमारा यह प्रेजेंटेशन अच्छा लगा हो तो इसे लाइक करें, शेयर करें और इसे सब्सक्राइब करें, so that you are notified of my coming lectures immediately. Thank you for watching. See you next time with some other lecture of interest. Till then, goodbye.